Let's decode three harmony problem. So let me start from some fact that it's saying that you have vertex u and v, and what we want to do is we want to make some pairs of a step s, which is what, which is u minus the subtree of v, subtree of u excluding subtree of v, and divide them into pairs. So obviously the number of vertices in this set must be even. That's obvious. And then it says that you can pair elements if blah blah blah, and it means that you should not have a king. So what is a king? So we call an element in a multiset king if it appears strictly more than half times in that subarray. So if some element appears in a set more than half, so it's the king of that subarray or multiset or something like that. So our goal now is to find if this multiset actually has a king or not. To solve this, first we need to understand that if we write the vertices in their Euler-Tour order using their starting time, whatever you call it, the subtree of u is something like this, and subtree of v is something like this. So we have two subarrays, and we want to know if we merge these two subarrays, there will be a king. That's it. So, but before that, we want to solve a problem that given an array and a few queries, each query gives you L and R and asks you to print king of L to R. To solve this problem, we use a sparse table. If you already watched our sparse table video and also our special node video, after that video, you could easily solve this problem. And we are gonna solve the problem as described. So let's start. And yeah, finding king of two subarrays isn't that much different with finding king of a subarray. So the problem is already solved. Let me start by defining n a of max n and then let me call this vector of int g max n, and let's start by getting the input like this, and okay, and let me go for a DFS. Then let's keep starting time and finishing time, and let me define time, and st is time plus plus, and for auto u from v, actually it's better to use its own type. If u is not p, go dfs, and ft is time, and let me input this array as TA, and then a of time is TA of v. And from this line on, the problem is completely about the arrays, no tree at all. That's it. So I'm gonna define my sparse table, which is log times max n. Log is 17. And let me, okay, we have an improvement here. It's p of 0, and this is, I'm directly building. And let me come with a vector appear that says that appear av, it appears at time. So we need that to count how many times a number appeared in a range. So let's move on. K is 1, K is less than log plus K for int I from 0, while I plus 2 to the power of K is less than or equal to I. Then let me find how I'm gonna fill this sparse table to make sure it's super efficient. Okay. Okay. This first level of K and I is gonna be maximum of this first table of K minus 1 and I and what? And count of this thing. And let me implement this function get, which is gonna be useful in the future too. X int L int R return appear x dot lower, lower bound appear x dot begin appear x dot end and L, and let's replace it with brand new rings minus R and return yourself too. We need that. So no, sorry, R minus L. So this function get returns a tuple where its first element is how many times x appeared in this range L to R, and also it will return x. So carefully look what I do here. I get maximum of get of this from I to I plus 2 to the power of K. Good. And good. And I do the same is I plus 1 to the power k minus 1. And finally, I get the second element of this tuple. Okay. So I have two candidates, and I get the maximum among them. That's it. That's what I do. So, and also it's good to implement function, another function get L int R C and C2, which goes and finds maximum of get CLR, get C2 LR, and return it. And then very easily I can use this function get here. I just need to write it down from L to R. This is one of my candidates. This is the other candidate. And that's it. Okay. That's super clean. Okay. So what I do now is I'm gonna have some queries. Where is queries? Queries, come on. Okay, they are coming in. First of all, if it gives us u and v, so I also I always do the vice versa thing, but it says that u is parent of v, ancestor of v, but I usually consider that v is, but not important. If not st of u is smaller than or equal to st of v, and ft of v is smaller than or equal to ft of u, or st of v minus st of u plus ft of v minus ft of u is odd, directly say no. Okay, directly say no. So no. Continue otherwise. Now I have two ranks and I want to find the king of this merged range, and I have some candidates. So first, let me come with my candidate. Before that, I think that I should change this. Like this, and then okay. Now let's cast it to double. And finally get the first element out of this. Actually, the second. Okay, good. So let me come with candidates, and finally we can solve. So let's implement function king from L to R. Then let's come with some, let's say nth is 0, it doesn't matter. And then let's start with some bits. If L minus R has this bit, we want to add 2 to the power of I to L. For that, what I do is, and is get of a range. Let me count this because we are going to change our position. Get from L to R. You have two candidates. One of them is M, and another one is first stable at I and P, and finally P plus equal 1 to the power of I, and finally return as works very well. And then I have two candidates, king of a starting time of U to a starting time of V, and second candidate is king of finishing time of V to finishing time of U. And now I want to find, actually it's not necessarily a king, it's some element that is a candidate for being king, but not necessarily the king itself. And finally, I need to pick one of them that has the maximum count. So let's say nth is same as item here. I'm gonna add a count of CX in both subarrays. So it's FTV to FTU, and we have CX here, and another tuple is the same but for C2. Looks like this. C2 seems good. And finally, scout. Oh, I just need to make sure it counts. Okay. And max count is okay, but we don't need tuple at all. We just need to compare these two numbers. That's it, because we don't need to print the candidate. I mean, the king. And let's define a set here. Oops. Okay. Scout is the max count times 2 is strictly more than a set. Yes. Otherwise, no. And that's it. Let me give the input, and also this one. Okay. Oh, if it's more, no, otherwise yes. Okay, I missed to do the DFS as always. If you watch the earlier videos, I missed to do DFS another time. And let's input this, let's submit. Sure. Okay, submitting. Okay, but before that, let me give it a good example like 3. Okay, we got wrong answer. I actually expected that to some extent. Let me give it the 1 2 1 3 1 query 1 2. It should print no, correct. 1 3, it should print no, correct. Let's do like this. It should print no, correct. It should print yes. Incorrect, yes. Do you agree with me? Answer is yes here, because yeah, look, we have 1 and 3, and 1 and 3 can be matched, so obviously it's yes. So okay, it comes to this part. Let's see what is the max count. Max count should be 1. It's 1. And is that ft of u minus ft of v? And okay, it changed to yes. But let me see if, okay, let's stop it and see if I did the same mistake somewhere else. Please submitting. Okay, it's going. And we can see AC in a few seconds. And that's it. Got AC.
Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.